So I'm the New South Wales Project Officer for the University of Adelaide. I actually live and work in New South Wales. I'm a teacher one day and I work for the university 3 days. So what I'll be doing tonight is talking about books that I've used to teach English in classroom context. Often I pick them because they relate to science subjects that I'm actually using. So I've also got some digital technologies tools, and I'm going to talk about how I link those back to the books. So what I've got here, and I'll just post it quickly because I want you to have these documents that I've made. So I've got a link here to the English outcomes that I feel are relevant to tonight. And I also have a gift, which I'm sure you will love. And it actually is a very extensive list of science and technology, engineering, math picture books that tie to the English syllabus. So what I've done is I've documented all of the books that I've found. A group of university project officers were contributing to the books every time we find something, and we write what we think it links to. So I'm going to start with the very, very obvious books of how you integrate computational thinking with English. And I'm going to start with If I Once Were a Wizard by Paul Hamilton. He is actually an Australian author, and this book talks specifically to outcome 3 in the science and technology syllabus, but it also has a really cute story about this little possum. It looks a little bit mousy, but I think he's catering for the American audience. So it's definitely an Australian book. It's got Australian native characters. You can actually then use this book as a jump. Use it for your grammar, for your spelling, for your direct speech, and then you can jump into algorithms and what they are. Now, for those who don't know, algorithms are step-by-step procedures, and they are used. Sorry, Mary. It started at 7, but I actually, for the first 15 minutes, it wasn't. There was no sound, so I started again. So I hope you don't. You haven't missed much. I've only been going for a couple of minutes. So that was the first book. So the second book is How to Code a Castle, Sandcastle by Josh Funk. And this, once again, is a book that is directly teaching you outcome 3 in science and technology in algorithms. An algorithm is a step-by-step procedure. And it's about this little girl that's trying to program her robot to build a sandcastle. So it's a really great way to demonstrate how instructions have to be directly taught. Now, I've actually used this book with stage 1, and the activity we did after this was, after we read it, was we actually were human robots and we had to give directions to each other. You could then go on to tie that into teaching with something like your Bebot or something like your Autobots. Oops, and of course I've just dropped it. So once you tie it into your Autobots, these are Autobots, and you also could tie it in a stage 2-3 classroom to your Spiros. Now, if you actually in an older classroom and you feel that human robots are mastered fairly quickly, what you can do is you could put a tumbler cup on top of your Spiro, and this becomes the base for your design and make, and you could turn this into a rocket if you're doing space, a ship if you're doing explorers. It could become an insect if you're doing living things. There's all sorts of things that could become. And you can also do the same thing with an Autobot with a shot glass. So I just got these in the reject shop. They're a couple of dollars and they fit on top of your Autobot. And this, once again, could become the base for a design and production. So you've actually got, starting with English, where you're using this to do procedure writing, grammar, or direct dialogue. You then move on to, let's write a procedure to control our Autobot or our Bebot or our Spiro, depending what year group you're in and what resources you have at school. If you have none of those, human robot. Get the students to write the procedure to be a human robot and make a jam sandwich. And Google that, it's hilarious. The teachers who are doing that just are literally doing exactly what they say. Pick up the bread, so they pick up the bread. Pick up the butter, put it down, and they just drop it. So if you Google human robot jam sandwich, you will see how someone else with no resources has turned this book and your how to code a sandcastle and your If I Were a Wizard into procedural writing experiences. Another way you can tie it into maths would be then to do a square. Get the students to stand up and give instructions to do a square. Now, I did that with the stage 2 class just last week. And what they did was they started by drawing a square. Then they had to write down the steps and they had to give instructions to the teacher to draw a square. Now, the follow-up lesson to that was procedure writing. So when the idea of doing your integration is that you're covering all of your outcomes, but you're not taking more time to cover different content. So by doing your properties of a square inside an English lesson, you still cover your concepts of your maths and it might be revision for year 4 or year 5. Properties of a square, and then you can do your procedure writing. So it's actually these types of books of how to code a sandcastle and If Once Were a Wizard, they're quite good books for introducing procedures. Another book, series of books that I like is Ada Twist the Scientist, Iggy Peck the Architect, and Rosie Revere the Engineer. Now, they are 3 books that are really, really great for teaching different STEM concepts. Now, STEM is a really big buzzword at the moment. It actually stands for science, technology, engineering, and maths. You can put an A in there for art if you like. The risk is that people think a coat of paint then covers the art, and that's not how it's supposed to work. But if you take your science, take 2 of those concepts, science, technology, engineering, math, and put them together, you're actually teaching STEM. Now, STEM is not a curriculum area. We don't have a STEM syllabus, we don't have a STEM curriculum. So what we have to do is we have to make sure that whenever you're teaching a STEM activity, think about what outcomes am I actually teaching. Now, by covering books like these, you're covering your English outcomes by reading. You're also covering your design outcomes, which is outcome 2 in the science and technology syllabus, design and production, where you use materials and tools to design for a specific need or solution. And so Rosie Revere has gender equity, it has resilience, and it also is talking about design in the particular theme of flight. So if you were to read this book, and I would propose all of these books may be read after lunch for 5 minutes while kids are sitting down and settling down. If you want, you can set, if you've got multiple copies, you can set them as reading activities inside reading groups. So once you've done this book, set your comprehension questions, set your comparisons. So for example, you might say, I'm going to compare, I'm just looking for this other book that I have here. I'm going to compare these 2 books. I've got Rosie Revere the Engineer with Andrea Beattie, or I've got Doll E by Shanda McCloskey. Now, all these books I've put in a link for you in the comments. So I could compare and contrast these books. I could talk about the audience. I could talk about the intent of the author. And I could use those to then stimulate a writing session where students may write their own story about a person who's resilient and overcomes adversity. This one is Dolly. She gets a toy that she doesn't like because it doesn't do anything. Funnily enough, it's a doll. And then what she does is she hacks the doll and adds a makey-makey to make it talk. It's quite cute. And so you can actually then integrate that into your digital systems. So when you're doing your programming, you would have your English outcomes for intent of authors and purpose for audience, writing activities where they might write an alternate ending or they might add another character. Boys might like to add a male character or write a similar story with a boy where he receives a toy he doesn't like. Girls may like to write an alternate ending or incorporate another character. When you add a makey-makey to that project, that is how she gets the doll to talk. have a look at. So if you haven't got Makey Makeys, this is the Australian version. It's called Shaky Shaky. And they do the similar things. The Shaky Shaky has a few more functions, and you can only buy that from Little Bird. Makey Makey you can buy from most online wholesalers for digital technology. So check. I'm not going to tell you a particular location to buy them because the prices change all the time. And what you need to do is do a search on the tool that you're looking for and then go to shopping. When you go to shopping, make sure you're looking for Australian websites and go down, and what you'll find is you'll find the cheapest price that way because the prices change all the time. So if you're looking at your outcomes, another outcome you might like to do is recognize, this is outcome 8B, recognize that there are different kinds of text when reading and viewing, and show awareness of purpose, audience, and subject matter. And then stage 2 would identify and compare the different kinds of texts. So we're looking at comparing text when reading and viewing to show an understanding of purpose, audience, and subject matter. So when you're comparing texts, pick 2 books that you just really like that are on a similar theme and start to compare them. So the next book that I'd like to talk about is grain-based, Yuno's Garden. I actually did this book as a 2-week unit inside a sustainability unit. And we talked about the environment, the ecosystem, so it's actually stage 2 living things. And you could do something with mythological animals inside of stage 3 outcomes for living things, characteristics and how animals adapt. But Yuno's Garden is great because it has a lot of maths content in it. So an example would be, it has a Fibonacci sequence, it has algorithmic progressions. So all these numbers up the top here, you've got patterns and sequencing of numbers. So while you're talking about doing this in English, and you might be talking about the different way they use the language and the different made-up words and how they actually use interest in illustrations to keep people's interest in picture books, you might be doing Fibonacci sequence, and you might be doing patterns of numbers and arithmetic progressions in maths, and you might like to actually build one of those houses in design and production. So all of a sudden your science unit on living things has actually got design and production, where you're constructing a shelter either for the animals or the people. You might be looking at sustainable cities, you might be looking at your maths, and then you've also got the purpose and intent of your language and the way the wording is used with made up words. Can students make up their own words in their writing? And another person you might like to compare that to is Dr. Seuss. And you could actually investigate Dr. Seuss and talk about how some of his words, like Grinch, have actually made their way into dictionaries and how that happens. Another example would, of course, be Shakespeare and his made-up language. Okay, another beautiful book by Drew Dable, The Legend of Rock, Paper, Scissors. Now, this book is great for onomatopoeia. It's great for cartoon-style books. So if you've got kids who aren't really interested in reading, you could introduce a unit on graphic novels. And another book that I have, which is for older students, is called, I'll have to publish it in the comments, I just can't think of it, but it's a graphic novel. And so books like this are great for onomatopoeia, comparing language, once again talking about different ways that people express their words in books and how that makes you feel. You could look at superhero comics and compare those. Now, the idea of this book is each of these characters in the book are the hero in their own space. So the rock is the hero of the garden, the paper is the hero in the study, and the scissors are the hero in the kitchen. And what they do is they win and nobody can beat them until they meet each other and they realise they're actually quite happy they found someone who can beat them. So how could this fit into an English unit? You could get the students to write an alternate ending where there's a fourth character. An example, my children used to actually play rock, paper, scissors, torpedo. I don't know who was the winner, but they thought it was awesome. You could have bomb, you could have fire. So there's lots of different ways that you could tie in writing by getting them to write an alternate ending. Stage 2 has got an outcome on writing and with digital technologies. So you could perhaps use something like Comic Writer to actually write your own comic strip. If you haven't got access to technology, you could build up some sort of story frame where they can just draw their look pictures inside each story frame, or get them to do it in groups where each person does one frame each, and that might actually save time and make the writing process quicker. So rock, paper, scissors is great because rock, paper, scissors is actually a program that's been written for the microbit. And anyone who knows me will know how much I love these. They're $30. Don't spend more than $30. Someone will try and charge $40 if you're not careful. You can buy a pack of 10 for $250. Pack of 10, $250. So if you have no money for technology, $250 will do you for at least a year. Then next year, you might be able to afford to add on to that. So you can actually buy little robots that go with these. But rock, paper, scissors, on shake, it displays a rock. On shake, it displays scissors or paper. Now, the benefit of this project, and I'll post a link to the code, this is already written for you. You don't need to do it. So you can actually have your English writing unit with your book. You can write your alternate endings. You can write examples of onomatopoeia and your dialogue. And then in science, you can actually build this and achieve your algorithms outcome, outcome 3, and your digital systems outcome, outcome 11. So this would be a stage 2 or a 3 activity. And once you've done that, you've also then got a maths activity. So your maths activity would be play rock, paper, scissors with your partner or your buddy and record win, draw, loss. Once you've recorded win, draw, loss, you might have played it 36 times. Record that information in a spreadsheet. Then get everybody in the class to record their information in the same spreadsheet. So while my win, draw, loss might not have shown me any sense of probability or chance because it was just random, when you put everybody's statistics into the one spreadsheet and add up who got a win, who got a loss, and who got a draw, you should be able to see a pattern of the win, draw, loss where you're playing it with your hands. Then you program your microbit, repeat the same activity with the microbit, and compare the results. Once you've compared the results, you can start to see, is the hand truly random? Now, there is a research paper, and if I can find it, I'll post it in the links later. There is a research paper that actually says you can win rock, paper, scissors by predicting what someone will play by what they played first. So you would think this would be a truly random event when you play rock, paper, scissors on your microbit. So that is an activity which ties in English, maths, digital technologies, and algorithms. So once again, you've got what the good thing about this process is you're going to be teaching your concepts and the idea of the game inside your English. So you're not actually photocopying worksheets from books that are just on random content to teach onomatopoeia or to teach your comic strip genre. You're just using random content. You're using content that the students can draw on later when you're doing your maths and your science. And the benefit of doing that is you're giving them double shots at learning and remembering how and why it works. Because then it increases the amount of vocabulary you can use, it gives you contextual vocabulary, which will help you build your word walls. And I'm hoping, even in stage 3, I'm hoping people still have word walls because the language that comes out of books like this, when you actually use them in the context of science and maths, actually changes the context of your language. So you'll actually use more probability, chance, and especially if you do it in your fourth character. So for stage 3, you might be looking at building your rock, paper, scissors, and the outcome actually is once you've built your program is modify. So in stage 3, they have to design and develop their algorithm and modify. So while you might use your outcome from the Make Code website to build your rock, paper, scissors game, you would then get them to modify it and build in a 4th character. So initially, we're all learning. The kids are learning and you're learning. So initially what you might do is you might do it together and you would step-by-step teach it, direct instruction. But give the kids an opportunity, and I'll just show you where you can go to get this code, because what you'll find is you've got, so this is the browser that you would use for your Make Code to build the project. I'm not sure where that's gone. And reference. So once you're on the Make Code website and you click on Let's Code, you would go to your reference and you would go to projects. And once you're in your projects, you have got a rock, paper, scissors game that has, so I've just posted right down the bottom there. You've got rock, paper, scissors. So once you go into click that link, it'll take you in. It gives you the instructions on how to design it. It gives you the instructions on how to code it and instructions on how to play it. The key to using this tool, the Make Code tool, is that you actually read all of the instructions. Make sure you read all of the instructions, because if you don't read the instructions, that's when you make mistakes. Now, what I did with the Year 6 class was we did this activity, we put it on the board, and we let them scroll through in their own time. What they did was they worked out, they had one-to-one computers, they put the instructions on one person's computer and they then used the code on the other computer. Some students put the instructions on one tab and had their code in another tab and flipped between them. So Year 6 could probably work quite well at their own pace by working through that project without your help. My advice when learning to do a new project with any technology is to actually do the project at home yourself. If you're teaching a new novel, you would actually read the book. You would read the book and you would make notes. So when you're teaching digital technologies, this is new for lots and lots of people. You have to pretend you're first year out. Really, doesn't matter how experienced you are. Even before I teach a new project, I do it myself. And that way, when I've done it myself, I feel more confident that I can teach it. So I want to encourage you to do them yourself, download it, test it. You get all excited because it actually works. And then when you go to school, you'll feel more confident because you know you've done it once. If you find you're having mistakes and trouble getting that to work, what I would do is if there's kids in the class who've actually got it, turn them into experts and get them to walk around and help. And once they solve a problem, how did you solve that problem? Ask them to help you understand how they solved it. And that way you're actually going to be able to increase your skills as well as giving them credit when they solve the problem. Okay, here's another book. So this is called The Tomorrow Book by Jackie French. And this book is great for design thinking. So it's great for imagination, it's great for narratives. So that it's not really that engaging in terms of pictures, but it's a great book in terms of thinking about alternative ways to view the world. So it's a great thing to read to get students to imagine what they want tomorrow to be and get them to write a narrative and write about something they're interested in. If they need stimulus and they haven't got that creative to think their own story, ask them to rewrite this one, add a character, write an alternate ending, or just redo the story so it's more interesting for them. You could then base this onto an art lesson simply because it's got a lot of Zen type diagrams in it. It's got a lot of mosaic with newspaper. So then you could do art lessons with that and different styles of art. You could maybe compare and contrast it to a Jeannie Little book. So like The Forest Where the Forest Meets the Sea. And compare and contrast, how are they similar and how are they different? How are the illustrations done in a way that might be more interesting or better for some people? So that's, and this also ties to design and production, which is outcome 2 in your science and technology syllabus. So once you tie in design and production, once again, remember that book we read yesterday? Well, today we're going to build something ourselves. And it gives you a great way to tie everything together so the kids aren't learning something new every hour. You actually have a consistent theme going through all of your lessons for the day or for the week. You might only do it for a couple of days. It doesn't matter. And by doing that, you actually then encourage them to think deeply about the theme that you want. Now, if your school doesn't have the books, your school, and you can't afford to buy them, the school can't afford to buy them, I would encourage you to explore your local library. And I've actually noticed there's a lot of people on here who are from my local area. So our library's going to have no books because everyone's going to run down there and get the books out. But if you can't, put them on a list, put them on a wish list for your librarian. So when she's looking at buying books, she's actually getting books that you're going to get. Now, I was in the library for 4 years in one of the schools I was in. And what we did was on the spine here, we put a small sticker. And so when the teachers are sort of flipping through the books on the shelf as you do, and you just see this patch of the book, this would have algorithms written on it. Some of this book would have design written here. And if you've got a book for STEM, this book would have STEM or engineering or design thinking. So that when the teachers were flicking through the books, they could actually find books on the theme of design or on the theme of maths. Now, in the link that I shared right back at the start of all the comments, I've actually shared with you a spreadsheet that I've got, which has got a whole stack of books in it and themes and how I see them fitting into key learning areas. So hopefully you will go back and find that useful. Now, this little book is my newest book. I love this one. I can't pronounce the man's name. Herb Tulay, I think his name is. And it's actually on art, mixing colour. And when I don't know if you've seen this book, but it says, rub the dot on the left gently. And when I rub the dot actually changes colour. And then it says, rub the other dot, and that dot will turn blue. Later on, it will say, shake the book. So I get to this one, and it says, shake, and all the picture dots move around. So this is a great one for what's next. What's next in the sequence? What's next in the pattern? And it's computational thinking, and it's also art, mixing colour, it's design. So at the end of the book, we end up with a totally different pattern. But it's about what's next and predicting what could come next in the story. So you've got your literacy and your narrative ideas tying into computational thinking, patterns, sequences, and a very clever and well-written book that would engage early stage 1 and stage 1 listeners. I've got 2 more books to say. There are so many, and if you go to your library, I'm sure you will find lots and lots of books. If you haven't got Aquatica, I'm sure you will find Mechanica. And I noticed that Catherine is here, and Catherine really, really inspired me with Mechanica last year. I taught Mechanica in the context of a stage 3 science unit where we talked about adaptations of living things. And Mechanica and Aquatica, if you don't know them, there's a type of books that kids just won't read. They're actually about hybrid animals that exist in a world where real animals have died out. So they fit beautifully into a sustainability unit. And what do we have to do to keep our animals alive? And then what I love most about this text, no child would ever read, I don't think. But what I did was I read this to my Year 5 class after lunch. And then the next day I turned up with the 4 pages photocopied, and each child got a copy of 1 page. They had to go through the highlight adjectives, circle proper nouns. They had to go through and underline any words they didn't know the meaning of, and then they had to actually go and look up those words in the dictionary. And we made a word wall of all the words in this book because I didn't know what they meant. And some of the words that annihilation, destruction, atmosphere, these really great words that are great for writing, but they wouldn't know them because they don't hear them. Now, essentially the story is that the animals all die out and somebody actually builds robots to take their place. and the animals start to crossbreed and they get their own breeds. So what happens is you end up, and lots of people have seen, you end up with a picture on one side, and you end up with a very sciencey way of presenting information with a lot of data at the bottom. So this is a great picture book for stage 3 to really engage language, grammar, adjectives, but also writing. So when we did our science unit, they all had to create their own animal, describe all of the adaptations. They had to write it in the theme, in the style of this book. So I actually only read one page from this book, and we talked about the structure of the writing so that they could reproduce that writing in their own animal. And at the bottom, there's a lot of data about the animal. So they got to make up how large is their animal, how small, what sort of power source or food does it eat, where does it live, and what country is it from. So by doing that, we actually demonstrated an understanding of a genre, that a science fiction genre, which isn't actually taught in a lot of primary schools. And then they also got to imitate that in their own writing. We used Google Slides to do the writing, and I just simply fed out a template to them, a 2-page template to them through their Google Classroom, and they all had to write, and then we printed those and we put them together to make a book. So Aquatic can also be used in high school to teach classification, but it could also be used in stage 3 to talk about the features of living things and how living things are related. I would even introduce the concept of science names and how animals have a science name, a Latin name, compared with their common name. So by doing that, you're introducing particularly Year 6 to concepts that they're going to be exposed to when they get to Year 7. So you're not teaching anything that they're not going to, that's going to make high school boring, but you're exposing them to the language that they're going to need when they get to high school as well. Now, something a little bit more complex is choose your own adventures and twister plots. So these are actually computational thinking at their best. This is where you have one story, one start with lots and lots of endings. And if you have a look on the very new copies of the books, they actually have all of the endings that you can possibly have. And I know with my son, we used to spend ages trying to make sure we read every single page and every single storyline. So these pictures on the new editions would have been very, very useful for us to try and work out, have we read all the endings? But what you can do in English is you can actually write stories where you pair kids up. You give it in a start of the story, and it might be a story you've read somewhere already, a novel that you've started in class, and they have to write alternate endings. What would have happened if they went left instead of right? So that they could actually think about alternatives, introduce new characters, and actually have new adventures. Do they die? It's okay if they die in a choose your own adventure, because you can go back and read it again and have another ending. And kids often write "and then I died" as a quick way to end a story. So in a choose your own adventure, it's okay to have a few "and then I died," but you would want to make sure, and you would emphasize, that at some point you're going to have a proper story with a proper happy ending, because that's what happens in these books. Just as a side note, if you have an original edition of An Abominable Snowman, it's actually worth a monster. So go through your old cupboards and find them, because this is a new one from K-Bart. But so all of those choose your own adventure, there's actually a lot of titles, a lot of twister plots, and there's also some I think that I've seen for emergent readers as well. So there is a tool online called Twinery, twinery.org. I haven't really had a huge amount of success with it, but it looks like it could be, I've just posted a link, it could be a really good tool. My problem with it is that you can't save, but you can download it and use it locally. So you might like to think about how you could use Twinery, and what it allows you to do is plan your choose your own adventure. So if you're not going to use an online tool, how you would plan it is you would use one page per story, per decision. And so when we're teaching this with computational thinking, we're talking decisions and branching. And the other term in the syllabus is iteration. So iteration is when you repeat and loop, going back up to another part of a story. Branching is when you have decisions. So that is a really great way to introduce branching and decisions into your literacy. Another way, if you don't want to use paper, make sure you number the pages so that you can keep track of what order they go in. If you go into, I've lost track of what I was going to say. If you go into Google Slides, you can actually then reproduce those pages as a slide page in Google Slides or in PowerPoint if you use Microsoft, and use hyperlinks. So Control K, if you select your text and press Control K, you can then, in Slides and PowerPoint, you can actually then link to another slide. It's actually quite easy. And if you can't do it, look up YouTube and how do I do a hyperlink in Google Slides or Microsoft PowerPoint, and you'll find lots and lots of ways to do that. Now, by doing it in Google Slides, just like when you were using spreadsheets for the rock, paper, scissors activity, by using those, you're teaching ICT capabilities. So remember, ICT capabilities is using a computer. Digital technologies is making and creating with a computer or technology. So by using it in Google Slides, you're teaching the kids how to actually do how to actually create a hyperlink, how to get a new slide, how to get a new pattern, how to make a new text box. All of those skills are really, really important skills for your students to have. And you can teach them incidentally as you're actually teaching your English lesson. Okay, so you don't actually have to have an hour of computer time. I would build in those just-in-time lessons into your English lesson. So you make your English lesson maybe a little bit longer and allow for that content. If you have to have an hour lesson of English, then you might just allow 10 minutes, allow time in that content to actually teach your ICT capabilities, because there's no time in the NES's hours for teaching ICT capabilities. And it's not science. It's actually across every single KLA. So anyone who says you're not teaching English when you're teaching Google Slides is actually not reading the English syllabus properly. ICT capabilities is every single outcome that has a little laptop at the end, just like Aboriginal perspectives and Asian perspectives, or ethics, sustainability. They're all capabilities that are inside every syllabus document. So I am going to hope someone answers that phone. Is there any questions? I actually haven't been looking. You can use hyperlinks in PowerPoint, Michelle. Yes, you can. So oh, I hope I'm not muffled. I know, it's funny. Okay, so if there's no questions, I'll actually finish up. I've posted a link to all these books that I've referred to, and I've posted a link to the outcomes that I've referred to. I'll add to that document the science outcomes and the maths outcomes. But I hope you can see how that literacy is linked to science and maths, history and geography, and how we can teach our literacy and our English concepts with a theme of our other subject areas. And by doing that, we're actually saving ourselves time. So I meet with NESA twice a year, and they have said if you're not integrating your content, they don't know how you're going to be teaching it all. So we all know we have an overcrowded curriculum. I really, really hope that you can rethink your syllabus documents and rethink your teaching so that next term you can try something new. Now, if you would like me to come and visit your school, I am a free service. I'm federally funded, and I've visited a lot of the people in the comments I've seen. I've been to your schools, and thank you for joining me. So if you would like to join me and or you'd like me to visit you, I go anywhere in New South Wales. We also have another project officer in Sydney who does Sydney schools, and we have a project officer in the ACT who is well versed in the New South Wales syllabus, and she visits a lot of schools in Western New South Wales and South Coast. So if you are interested, if you're in another state and you've persevered, thank you for listening to my live on New South Wales syllabus. But if you are, you can actually go into our CSER website and put in a request. We have project offices in every state. And we also, for anyone who has listened to this point, because you participated in the webinar, feel free to apply for our online lending library. It's a free lending library. It operates a bit like the Department of Education STEM Share program. In fact, they copied us. So we're quite proud that it was so successful that they thought it would work for them. So if you're not in the public system, you're welcome to actually apply. When you put in your request, make sure you put, I watched Meredith's webinar on computational thinking. And by doing that, you will actually be eligible to apply for a kit. We do prioritise schools that have actually done their training with all of their teachers. So, and we also prioritise high Indigenous and low ICSEA numbers. So if your ICSEA is less than 1,000, so we have got a limit of kits, but I have about 100 and something. So hopefully you'll be able to get a kit. If you want to contact me directly, please private message me. Don't put your email addresses in public comments. That's not online safety. And so please message me direct, and I'll send you my email and my mobile, and you can contact me that way. All right, thank you very much for attending, and I'll post this to my page so you can catch up if you missed. I'm sorry if there was confusion about the start times. I thought it started at 7, but you can feel free to go back and watch. Okay, thank you. Bye.